All right. Hi, this is Miss Tringle. This is 11/7, which we'll also be taking 2 days for this year. So we're looking at cones. 11/7 focuses on cones, but we are doing surface area and volume. So our essential question today is, what is surface area? We've talked about volume, the space inside a shape. Now we're talking about what is surface area. And our learning target, I can find the volume and surface area of a cone. So surface area, what is surface area? I'll even just answer that right up here. It's basically the area, the total area of all faces, bases of a 3D figure. So it's kind of like, if you have a cereal box or a Kleenex box and you find the area of each side and add it up, that's the surface area. All right, so surface area for a cone. Think about the net of a cone. So here you have kind of that wedge part, and then you have that little circle part. So the area formula for that circle is pi r squared. The area formula for the wedge part is either pi rl or pi rs. I've seen it written either way. And S or L are the slant or lateral height. And then the height, why we don't call it H, is that would be this. Okay, that would be perpendicular. So H is used in the volume formula of a cone, and L or S, we'll use L because your textbook uses that. L would be used for surface area. So here is your surface area formula, pi r squared, that's the circle part, plus pi rl. All right, here is the volume formula of a cone. 1/3 base times height is what most standardized test formula sheets have, which you'll notice is actually the same as a pyramid, because it is just like a pyramid in that it ends in that vertex. So kind of like how a cylinder and prism had base times height, a pyramid and a cone have 1/3 base times height. Now I'll erase this so you don't get confused. They did write it out here, just putting in that the base of a cone is always a circle. So they changed big B to pi r squared. And please don't get confused. Volume uses H. H is always perpendicular and not L, which would be that. All right, so that's something students commonly get confused. All right, let's try some examples. So find the surface area of the cone, of the right cone. And right just means it's not like tilted. So find the surface area. We need to do pi r squared plus pi r l. So pi r squared, the radius is 4. If you just want to put 16 because you square it right there, that's fine. Plus pi times r times l. And then sometimes we'll do things in terms of pi. So we'll make this like a 16 pi. Where did the 16 come from? 4 squared. And then we'll do 4 times 6 and we'll make that a 24 pi. And then we can add the 16 and 24 and get 40 pi. And it's no problem with me if you leave your answer like that. Sometimes you'll multiply it out. Obviously, you're not going to go to Home Depot and ask for 40 pi, worth of linoleum to cover your bathroom floor. You'd want to multiply it out. But it is technically more exact if you leave it in terms of pi. All right, example 2, find the volume. So really slowing down, reading the questions, picking the right formula is also important in this section. So volume is 1/3 base times height. Remember, the base is a circle. So I'm going to go ahead and change that to pi r squared. And I'm going to fill in what I can. So 1/3 pi, the radius is 2.2. That's on my picture. And the height is 4.5. So it looks kind of long, but you really can put this whole thing into your calculator at once. Or what I do, again, not that you have to do this, is I do all this and then I divide by 3 at the end. Although some people forget to divide by 3, so they like to put in 1/3. Up to you, 22.8 cubic centimeters. All right, number 3. Now we have similar cones, okay, similar cones. So hopefully you're thinking K, and we're talking about volume, so K to the third. All right, so find the volume of cone B. So first let's find our scale factor. The radius of circle A is 3. The radius of circle B is 9. Whoops, my 3 disappeared. So what is K? What is the scale factor? What do I do? 3 times what? Gives me 9. 3. So my scale factor is 3. For volume, I need to take my scale factor and cube it. So K to the third, K cubed is 27. 3 times 3 times 3. So I need to take the volume of cone A, 15 pi, and I need to multiply that by 27 because the volume of cone B will be 27 times bigger, and that gives me 405 pi feet cubed. And again, I'm going to leave it in terms of pi, but you certainly can multiply it out if you want. That's fine to do that. All right, let's look at example 4. All right, find the volume of the composite solid. So we need to find the volume of the cylinder, and we need to find the volume of the cone and add them. So cylinder has 2 bases. Volume is base times height. We don't need the 1/3. The base of a cylinder, what color should we do? Green. The base of a cylinder is a circle. How do you find the area of a circle? Pi r squared. So I'm going to change that. And then let's plug some stuff in. So the radius is 6. If you want to do 6 squared, make that 36. The height of my cylinder is 5. So let's see, the cylinder, 36 times 5. 36 times 5, is that 180 pi. So that's the cylinder. So cylinder, 180 pi. Now we still need to do the cone. So the cone is 1/3 base times height. 1/3 base times height because it's a cone, ends in that vertex. The base, big B, of the cone is also a circle. So I can go ahead, I'm going to just zoom in here. I can go ahead and make big B pi r squared, and we can plug in what we know. So they actually have the same base, right? Because it's the top of the cylinder is the bottom of the cone. So the radius is still 6, or 36 pi for that, and the height of the cone is 4. So if I'm doing that, I have 36 right here. This is 36. 1/3 of 36 is 12. 12 times 4 is 48 pi. And you can use your calculator if you want. So the cone is 48 pi. Let me zoom out a little bit here. Get a little highlighting. So we have 48 pi for the cone. We'll do yellow. And the cylinder was 180 pi. Remember, for a composite shape, we need to add them. So we need to add 180 pi plus 48 pi. And I'm getting 228 pi meters cubed for my composite volume. All right, so that's what I have for 11.7. The big ideas homework will be up. And the summary, what is surface area? I think I wrote that out, and you might be able to find even a better definition too. What's the formula for the surface area of a cone? What's the formula for a volume of a cone? What other 3D figure has the same volume formula using big B? And then how is finding the volume different for those two figures? So just to clarify a little bit for the green question, what other 3D figure? Hopefully you're kind of thinking a pyramid has the 1/3 base times height. So that's in a way how they're similar. But what is kind of different about finding the volume? Like talk about the bases. The base of a cone is always a certain shape versus a pyramid.